Hello guys, welcome to part 5 of our episode The Mystery of Motion. Today we will learn about the graphical representation of motion. One useful way of representing motion can be a graphical representation. It provides a visual representation of how position, velocity and acceleration change with time. Such graphs help us in comparing the motion of two objects, in calculating physical quantities, or in identifying whether the motion is uniform or non-uniform. As you have learnt in mathematics, graph comes in various forms, each suited to different types of data representation. To describe motion, we will use graphs to show dependence of one physical quantity, such as position, velocity, or acceleration, on another quantity, such as time. Let us learn to plot and interpret line graphs of motions. All the graphs that we will discuss in this chapter are for motion in a straight line, in one direction only. In this special case, the distance traveled and magnitude of displacement are equal, and speed and magnitude of velocity are also equal. If position is 0 at time 0, then the position time graph is same as the distance time graph, and the velocity time graph is the same as the speed time graph. Let us plot a graph. Take a sheet of graph.
What if we could actually watch a graph being born from motion? Now let's make it faster. The graph isn't just showing where the object is. Its slope tells us how quickly its position is changing.
On the graph paper, draw two lines perpendicular to each other. Their point of intersection is known as the origin O. Mark the horizontal line as OX. It is known as the x-axis. Similarly, mark the vertical line as OY. It is called the y-axis. We need to decide which quantity, time or position to be shown along each axis, and we will show time along the x-axis and position along the y-axis. Determine a suitable scale for each quantity to represent it on the graph paper. We need to choose scales that allow us to represent the data effectively and conveniently while utilizing the available space. This scale can be x is equal to 5 divisions is equal to 1 second, and y-axis is equal to 5 divisions is equal to 20 meters. Use the chosen scale to mark values for time, that is 1 second, 2 second, 3 second, and so on the axis from the origin. Similarly, mark values for position along the y-axis. Begin plotting points on the graph paper to represent each set of time and position values. At time 0 second, the position is also 0. The point corresponding to this set of values on the graph will therefore be the origin itself. At 1 second, the position of vehicle is at 20 meter. To mark these values, look for the point that represents 1 second on the x-axis. Draw a line parallel to the y-axis at this point. Then draw a line parallel to the x-axis from the point corresponding to the distance 20 meter on the y-axis. The point where these two lines intersect represent the position 20 meter at time t is equal to 1 second on the graph. Similarly, plot on the graph paper all the points corresponding to position of the vehicle at different instants of time. Once all the points are plotted, connect them to create the position time graph for the vehicle's motion. It is a straight line for the data given in the table. This was an example of plotting a position time graph. The intermediate points represent the possible values for position of a vehicle at intermediate times. They are correct if vehicle is moving with a constant speed. Always remember that a graph is not a route map. It does not show the route, but how the position of the object changes with time with respect to the origin. For a vehicle starting from rest and speeding up, the data for position and time are given in the table. Now that you know how to plot a graph from the data given for the motion of an object, let us learn how to interpret the graphs. The position time graph represents the motion of object, that is the change in the position with time. You have already plotted two position time graphs. Now, what information can you obtain from these graphs about the motion of the object? What does the shape of the position time graph indicate about the nature of motion? As we can see, a straight position time graph indicates that the object is moving with a constant velocity. On the other hand, a curved position time graph indicates that the velocity is not constant and thus the object is in accelerated motion. In the position time graph, we plotted. Consider a part say AB of the graph. From A, draw a line parallel to the x-axis and another line parallel to the y-axis. Repeat the same for B. Extend the horizontal line from A and a triangle ABC is formed. What do the sides BC and CA of the triangle represent? BC represents the change in the position, that is S2 minus S1, and AC represents the change in time, that is T2 minus T1. By dividing the change in position BC by the change in time AC, you get the average velocity. By extracting values of time t1 and t2 and distance s1 and s2 from the graph, that is s2 is equal to 80 meters, s1 is equal to 40 meters, t2 is equal to 4 seconds and t1 is equal to 2 seconds. The magnitude of average velocity can be calculated by the formula v is equal to s2 minus s1 upon t2 minus t1. That is, v is equal to 20 meter per second. BC by CA gives us the slope. From a position time graph, by finding the positions of the object at two instants of time, you can calculate the average velocity. The slope of the line AB connecting initial position A and final position B. The slope of a line is the steepness of the line. The slope of a graph gives information about the rate of change of the quantity shown on the y-axis with respect to the quantity shown on the x-axis. If we get a steeper line, it means we have greater velocity. If the line is less steep, then you have lower velocity. And if we get a horizontal line, that is, we have zero velocity. This follows directly from the explanation that the slope of a line is its steepness and that the slope of the position time graph gives information about the rate of change of position. What does the graph shown in the figure indicate about the nature of motion of the vehicle? The position of the vehicle is 40 meters from the origin and it is not changing with time, that is, it is constant with time. Thus, the vehicle is at rest at 40 meters from the origin. A straight line parallel to the time axis on a position time graph represents a stationary object. In this case, the position time graph is not the distance time graph. The position time graph of two objects A and B are given in the figure. The magnitude of average velocity of which object is higher? We know that by making lines parallel to the axis as shown in the figure. It is found that the displacement of the object B is more than the displacement of the object A for the same time interval. That is, the slope of the line for B is steeper than the slope of the line for A. Thus, the velocity of B is higher than that of A.
Let's see how velocity changes with time. For constant motion, we get a straight horizontal line. Faster motion gives us a line higher up on the grid, and the area underneath tells us how far it's traveled.
Velocity time graph of an object in motion represents the change in its velocity with time. In a manner similar to the position time graph, you can plot velocity time graphs. Let us take the example of a car moving in the same direction on a straight stretch of a highway at a steady velocity of 72 km per hour or 20 meter per second. The velocity time graph corresponding to it is as shown. Consider another car that starts moving from rest and its velocity increases with time as shown in the table. The velocity time graph plotted for this is as shown. Consider yet another car moving with a velocity of 15 meters per second. Its velocity decreases with time as shown in the table, and its velocity time graph is as shown. When the velocity of the car is constant, the velocity time graph is a straight line as shown in this figure. It is a straight line parallel to the x-axis and the acceleration is 0. The second velocity time graph indicates that the velocity is increasing with a constant acceleration in the direction of the velocity. The third velocity time graph indicates that the velocity is decreasing with a constant acceleration opposite to the direction of the velocity. Which physical quantities can be obtained from a velocity time graph? Apart from finding the magnitude of velocity of the object at each instant of time, what other physical quantities can be calculated from the velocity time graph? We found that velocity can be determined from the slope of the straight line on the position time graph. What can you find from the slope of the straight line on a velocity time graph? The slope of a line on the velocity time graph gives how fast the velocity is changing with time, that is the acceleration. Now consider the graph shown in the figure. Consider the part of the line AB. Suppose at time t1 corresponding to point A, the velocity is denoted by u, and at time t2 denoted corresponding to point B, the velocity is represented by v. Can you calculate the acceleration from velocity time graph? By dividing the change in velocity bc by change in time ca, we get a is equal to v minus u upon t2 minus t1 is equal to bc by ca. Acceleration then comes out to be 0.5 meter per second square. Can you calculate some other physical quantity from the velocity time graph? Area enclosed by the line on the graph and time axis. Does the area of the shaded part represent some physical quantity? OA is the magnitude of velocity and OC is the time interval. So area of rectangle OABC is equal to OA into OC is equal to velocity into time interval. Since in this case the velocity is constant, it is equal to the average velocity. We can say that the area of rectangle OABC denotes displacement. Substituting the values from the graph, we obtain displacement between 0 second and 6 second is equal to area of OABC, that is equal to 20 meter per second into 6 second is equal to 120 meter. That comes out to be the displacement. This is the displacement of the car from the origin in 6 seconds. You have found that the area enclosed by the velocity time graph and the time axis for a desired time interval is equal to the displacement in that time interval. How can you determine the displacement from the graph given in this figure? Suppose you find the displacement between 10 seconds and 20 seconds, corresponding to which graph points are A and B. We calculate the area between AB and time axis to obtain the displacement of the object which is moving with a constant acceleration. Thus, displacement between 10 second to 20 second is equal to area of rectangle ABDE, ACDE plus area of triangle ABC. This is the displacement of the car between 10 second and 20 second, which comes out to be CD into DE. CD, that is the area of rectangle ACDE, plus half into BC into AC, which is the area of triangle ABC, which comes out to be 75 meter. We learned that by finding the slope and area from velocity time graph for motion with constant acceleration, we can determine acceleration and displacement respectively. You learned how to represent motion by graphs. In the next video, we will learn about the equations of motion which describe the motion of
Like, share, and subscribe to AK Physics 47.